Quick revision. Seba Class 10. General Science. Chapter 5. Periodic Classification of Elements. For HSLC 2025. Important questions and answers in one short video. Important questions for HSLC 2025. 1-mark questions. 1. What is the basis of Mendeleev's periodic table? Answer. Mendeleev's periodic table was based on atomic mass. Mendeleev's periodic law. The properties of elements are a periodic function of their atomic masses. Elements were arranged in increasing order of atomic mass, and elements with similar properties were placed in the same group. 2. Define modern periodic law. Answer. Modern periodic law states that the physical and chemical properties of elements are a periodic function of their atomic number. This means, when elements are arranged in increasing order of atomic number, their properties repeat periodically. Proposed by Henry Moseley in 1913. Basis of the modern periodic table. 3. How many groups and periods are there in the modern periodic table? Answer. The modern periodic table has 18 groups, vertical columns, 7 periods, horizontal rows. 4. What is valency? Answer. Valency is the combining capacity of an atom, indicating how many electrons an atom can gain, lose, or share to achieve a stable electronic configuration, octet duplet rule. Example. Sodium, Na, valency is equal to 1, loses 1 electron. Oxygen, O, valency is equal to 2, gains 2 electrons. 2 to 3-mark questions. 5. Why are noble gases placed in group 18? Answer. Noble gases are placed in group 18 because they have a completely filled outermost shell, stable electronic configuration, and do not readily react with other elements. Example. Helium, He, is equal to 2 electrons, neon, Ne, is equal to 8 electrons. They have valency is equal to 0, making them chemically inert, unreactive. 6. Write to limitations of Mendeleev's periodic table. Answer. Although Mendeleev's periodic table was an important step in classifying elements, it had some limitations. 1. Position of hydrogen was placed in group 1, but it also showed similarities with group 17, halogens. Its correct position was uncertain. 2. No fixed position for isotopes. Isotopes of an element have different atomic masses but the same chemical properties. Mendeleev's table was based on atomic mass, so isotopes could not be placed properly. Conclusion. These limitations were later resolved in the modern periodic table, which is based on atomic number instead of atomic mass. 7. Why does atomic size decrease across a period? Answer. Atomic size, atomic radius, refers to the distance between the nucleus and the outermost electron of an atom. Reason for decrease. Across a period. 1. Increase in nuclear charge. As we move from left to right in a period, the atomic number increases, meaning more protons are added to the nucleus. This increases the attractive force on electrons. 2. Same number of shells, electrons are added to the same energy level, but due to stronger nuclear attraction, they are pulled closer to the nucleus, reducing atomic size. Example. Lithium, Li, beryllium, Be, boron, B, carbon, C, oxygen, O, fluorine, F. Atomic size decrease from left to right. Conclusion. Increasing nuclear charge pulls electrons closer, reducing atomic size across a period. 8. How does metallic character change across a period and down a group? Answer. Metallic character refers to an element's tendency to lose electrons and form positive ions, cations. Across a period, left to right. Metallic character decreases. Reason. Increasing nuclear charge pulls electrons closer, making it harder to lose electrons. Example. Na, most metallic, MgAls, IPSCl, least metallic. Down a group, top to bottom. Metallic character increases. Reason. atomic size increases, outer electrons are farther from the nucleus, making them easier to lose. Example, LINAK are BCS, most metallic at bottom. Conclusion, metallic character decreases across a period, but increases down a group. Nine. Why are elements arranged according to atomic number and not atomic mass? Answer, modern periodic table is based on atomic number, Z, instead of atomic mass, A. Because 1. Atomic number is a fundamental property. Atomic number, number of protons, uniquely identifies an element, whereas atomic mass can vary due to isotopes. 2. Proper position of isotopes of an element, example, carbon-12 and carbon-14, have different atomic masses but the same atomic number, so they can be placed correctly. 3. Correction of anomalies in Mendeleev's table, elements like argon, Ar, and potassium, K, were misplaced when arranged by atomic mass. The atomic number arrangement fixes such inconsistencies. Conclusion, arranging elements by atomic number provides a more accurate classification, maintaining periodic trends. 10. What are Dobereiner's triads? Give an example. Answer, Johanna Dobereiner, a German chemist, proposed Dobereiner's triads in 1817 as an early attempt to classify elements. Definition. Dobereiner grouped elements into sets of 3 elements, triads, where the atomic mass of the middle element was approximately the average of the other 2 elements. The elements in a triad had similar chemical properties. Example, alkali metal triad. Element, atomic mass, lithium Li, 7, sodium Na, 23, potassium K, 39. Average of Li and K. 7 plus 39 2 is equal to 23. This matches the atomic mass of sodium Na. Conclusion, though Dobereiner's triads helped in classifying elements, it was limited to only a few elements and was later replaced by better classification methods. 11. Explain the trends of atomic size, valency, and metallic character in the modern periodic table. Answer 1. Atomic size, atomic radius. Across a period, left to right decreases because increasing nuclear charge pulls electrons closer. Down a group, top to bottom increases as more electron shells are added. Example, LIBEPCNOF, decreasing across a period. 2. Valency. Across a period, first increases from 1 to 4 and then decreases from 4 to 0, heavy check mark. Down a group remains the same since elements in the same group have the same number of valence electrons. Example, group 1, LINAK, has valency 1, group 17, FClBr, has valency 1. 3. Metallic character. Across a period, decreases as atoms hold their electrons more tightly due to increasing nuclear charge. Down a group, increases because larger atoms lose electrons more easily. Example, NaMgAl, decreasing across a period, LINAK, increasing down a group. Conclusion, these trends help in understanding the properties and reactivity of elements in the modern periodic table. 12. What were the achievements and limitations of Mendeleev's periodic table? Answer, achievements. 1. Systematic arrangement of elements. Mendeleev arranged elements based on atomic mass, which grouped similar elements together. 2. Prediction of new elements. He left gaps for undiscovered elements like gallium, Ga, and germanium, Ge, and predicted their properties correctly. 3. Correction of atomic masses. He corrected the atomic masses of elements like beryllium, Be, indium, In, and gold, Au. Limitations. 1. Position of hydrogen, showed properties of both group 1 alkali metals and group 17 halogens, making its position uncertain. 2. No place for isotopes. Isotopes, same element with different atomic masses, could not be placed properly. 3. Irregular positioning of some elements like argon, Ar, and potassium, K, were placed incorrectly when arranged by atomic mass. Conclusion: despite its limitations, Mendeleev's table was a major step in the development of the modern periodic table. 13. Why is the modern periodic table better than Mendeleev's periodic table? Answer: 1. Based on atomic number. The modern periodic table is arranged by atomic number, Z, which is a more fundamental property, while Mendeleev's table was based on atomic mass, which led to incorrect placements. 2. Correct position of isotopes. Isotopes, same element with different atomic masses, could not be placed in Mendeleev's table. In the modern periodic table, isotopes have the same atomic number, so they are placed in the same position. 3. Proper grouping of elements. The modern table correctly groups elements with similar properties, unlike Mendeleev's table, where some elements, example, argon and potassium, were misplaced. Conclusion: the modern periodic table is more accurate, systematic, and solves the issues of Mendeleev's table, making it the most widely accepted classification of elements. 14. Describe Newland's law of octaves and its limitations. Answer 1. Newland's law of octaves, 1866. John Newland arranged elements in increasing order of atomic mass. He observed that every eighth element had properties similar to the first element, just like musical notes sa, re, ga, ma, pa, dha, ni, sa. Example: lithium, Li, sodium, Na, and potassium, K, showed similar properties. 2. Limitations of Newland's octaves. 1. Only worked for lighter elements. It was applicable only up to calcium, Ca, after which the pattern broke. 2. Did not leave gaps for undiscovered elements. New elements did not fit into his table, making it inaccurate. 3. Dissimilar elements in the same group, elements like cobalt, Co, and nickel, Ni, were placed with fluorine, F, and chlorine, Cl, even though they had different properties. Conclusion: Newland's law was an early attempt but failed for heavier elements. It was later replaced by Mendeleev's and the modern periodic table.